I'm going to go ahead and get started then. Welcome everyone to the seminar. My name is Kevin DeWalt. I'm going to jump right into things. Let me tell you a little bit about my background and why we're here. First off, my name is Kevin, and I am co-founder of ProLego along with my business partner, Russ Rands. And so if you hear me mention the name Russ today, that's what I'm referring to. We started the company a couple of years ago to become really a boutique AI service provider to large enterprise companies. And so we spend our days helping banks and insurance companies and telecom and automobile learn how to adopt AI technology. But as far as my own background goes, I recognize that a lot of you here are entrepreneurs or maybe looking for small company product ideas. And so I've been doing this for about 30 years. I did my graduate work when I was at Stanford in the early 1990s in neural networks, right during the height of the AI winter. And several decades later, I can finally put all of that math to good use in my day job. But I've been in tech and startups my whole career. Been a founder a number of times, worked as a venture capitalist. I'm still an active angel investor, and I've done all kinds of large infrastructure, tech, data processing work in large companies. Sort of the biggest of the big that are always looking for a competitive edge, intelligence, financial services, on telecom, the usual suspects. So I would imagine that most of the challenges and questions you have, I can probably answer. And if I can't answer them during the presentation, I will do my best to do so during the webinar, during the Q&A afterwards. Okay, so I want to paint a little context for what you can expect today. When Russ and I started the company 2 years ago, one of our missions was to help people understand what AI is and what we can do with the technology. And when we look around the universe, we find that most of the information out there about AI falls into one or two buckets. It's either high-level sort of marketing fluff, robots, automating stuff that's basically functionally useless, or it's so detailed and technical, like take an online TensorFlow course, that for your average business person or your entrepreneur, it doesn't really help you answer two questions, and that is, what is this tech and what can I do to it? And so that's what we're going to try to deliver today. For context, if you get lost, if you're unclear, if you want more details, everything I'm going to talk about today is captured in our book. It's called Become an AI Company in 90 Days, and you can download a free e-copy from our website. The URL is up there. It's at our website, prolego.io. And we think it's really the first practical business book on AI. So whenever I talk about tech to anyone, rather than just kind of blather information at you, I want to give you very specific skills you can use, things that you can take and apply to your job right away. And so by the end of this 45 minutes, I want you to have two skills. One is that I want you to understand AI basics. So when you go into a meeting and somebody talks about machine learning or training data, you're going to know what they're talking about. And so if you're trying to recruit an engineer or you're talking to a potential customer and you hear somebody in the room say something like, in Q2, we're going to apply machine learning to our data lake, you're going to know that that person doesn't know what they're talking about. So we're going to help explain what those words mean and how can you apply them. And the second, I'm going to give you some specific tricks you can use. This is the stuff that I actually use in my day job with my clients to identify opportunities for using AI. Some sort of simple product patterns you can use to look for new business opportunities and new product ideas. Okay, so let's jump right into it. Okay, part one, let's talk about some of the fundamental AI fundamentals. What do all of these words mean? So first, if you're confused about what the term AI means, you're not alone. I find this is one of the most hackneyed, confusing terms in the industry, and I'll just explain to you how I use it. AI just means intelligent computers. If you want to call your pocket calculator AI, go right ahead and do so. It's just a general term I use to talk about the state of the industry and where we are in time. So just general term, AI just means thinking machines. Machine learning is a type of AI, and that's why on your screen you see that it's the side of the Venn diagram. And it's a different way of programming computers. And machine learning is a really important term, and I'm going to explain to you exactly what that means. And finally, another term you may hear is deep learning. Deep learning is a type of machine learning, and it represents the state-of-the-art AI. So to summarize, AI, general term, just means thinking computers. Machine learning, a specific way of building software. And deep learning is a type of machine learning. Okay, so let's talk about machine learning. But before we talk about what machine learning is, let's talk about what machine learning isn't. So 99.999% of all software that you're ever going to see is built like this, with a developer or a programmer explicitly telling a computer how to perform a task. And so I've got some simple pseudocode on the screen here. This is not a language, it's an example of some type of code. And if you've had any kind of programming background, you can kind of look at this and say, okay, I see what this, this code is supposed to do. It's going to print out the time once a minute for 10 minutes, right? So runs through a loop, 1 through 10, prints out the time. So my question for you is, how did the developer, the person that wrote this software, know what to type? Like, why did the developer know that it was supposed to go from 1 till 10 and not 1 to 11? And why is the system waiting every minute and not every 30 seconds or every 59 seconds? Like, how did the programmer know what to do? And the answer is somebody told her how to do it, right? A human being, whether that was a customer, a boss, a product manager, maybe it was a specification, maybe it's information they learned in a log file, but somehow they got information from an external agent that described a problem. And then they went in them and told the computer how to solve the problem. So the developer looked at the world and developed this abstract language we call programming, which it used to instruct the computer. Okay, I know I'm belaboring this point, but it's a critical topic because machine learning doesn't work like this. Machine learning is a different way of programming computers. And in machine learning, a developer uses data to train a model how to perform a specific task. We're going to come back to this definition a lot. So this might seem a little abstract to you if you're not familiar with these terms. So let's start with an example. Let's pretend for a minute you've got a new startup idea or a new product idea, or you're a services company trying to provide software services to an industry. And let's pretend for a moment that that industry is a bunch of scientists who are trying to detect earthquakes. And so they've got a bunch of sensors scattered all over the United States, maybe at fault lines, maybe in the Midwest, and those sensors gather signals. And the scientists use those signals to try to predict an earthquake. So what do those sensors gather? Things like temperature, pressure, vibration, time of day, humidity, any information that might be predictive of an earthquake. And all that information is coming into the scientists. Well, you can imagine that the scientists that have to gather this information don't want to look at every signal from every sensor. That would take too long and be too tedious. So they're looking for you to design an intelligent signal alert system, a system that would sift through all of those signals and only notify the analysts or the scientists when they need to pay attention to a signal because it might indicate a potential earthquake. So let's start off pretending like we're going to build this system as a traditional software development project. So what you would probably do as a developer is sit down with a scientist and say, hey, tell me what makes an interesting signal. And they might tell you something like, well, if it's in an important region, it's interesting. For instance, if it's in the San Andreas Fault in California, I really care about it. If it's in the middle of Birmingham, Alabama, which doesn't have earthquakes, I probably don't. If the sensor's in maintenance, I don't want to know about it. If the vibration starts picking up, maybe I do want to know about it. If there's additional pressure on the sensor, maybe I want to know about it. I don't know what the rules are, but the scientist would probably describe what they want. And then the programmer would go in and build software that tries to apply that logic and what the scientists want to identify signals that might be interesting to the scientists. Okay, pretty straightforward, basic programming right here. The problem with this kind of software is that it can get pretty complicated as you have so many exceptions. And if you want to know that a sensor's in this region but not at this time, and you want to know that there's a certain amount of vibration but only if it's followed by additional vibration, as the logic gets more and more complicated, this software can get really, really complex. It gets hard to maintain. It gets brittle. It doesn't adapt as well. It doesn't adapt to changes. And it doesn't work as well in the long run. So it gets more expensive and doesn't work as well. So that's why a lot of companies are increasingly using machine learning as an alternative to building software like this. So again, let's go back to our definition. In machine learning, a developer uses data to train a model how to perform a specific task. So if we were going to build our intelligent signal alert system using machine learning, step one would be to go and gather the data. We would sit down with a scientist or maybe their IT department and we would say, hey, let's put together two spreadsheets. One spreadsheet has all of the interesting signals, and another spreadsheet has all of the not so interesting signals. And we're going to split them up into two different folders. And once we have that data, a machine learning engineer is going to take it and feed it into an algorithm or a model that's going to generate predictions. And we're going to feed each one of these signals into the algorithm. And it's going to try to predict, is it interesting or is it not interesting? And every time it makes a prediction and gets it right or wrong, we're going to give that feedback back to the algorithm. So if we start showing this algorithm enough examples, eventually it's going to get good enough to the point where it's able to predict whether a signal is interesting or not. And that is machine learning. If you get nothing else out of my discussion today, an understanding of what machine learning is and isn't is valuable career advice you're going to be able to apply in the next decade. I hear too often people using this term out of context without really understanding what it means, but it really is just a different way of building software. So to summarize, the traditional way of building a system like this would be the programmer explicitly telling a computer what to do. But in machine learning, we take examples, we feed it to an algorithm, and we train the algorithm how to know how to do something. In this case, make a prediction. That's machine learning. Okay, so let's dive into deep learning. So deep learning is, as I mentioned before, is a type of machine learning, and it's also the state of the art in AI. And I think it's fair to say that the only reason we're talking about AI today is because of deep learning. If you want a really easy read explanation for why this is happening now and what the big picture is, I highly recommend this article in the New York Times Magazine. It's about a year and a half old, but it's still excellent and very relevant. It's called The Great AI Awakening, and it's about the history of what happened at Google and neural networks and how they started using it for machine translation. So an excellent background on the technology if you're interested. Okay, so let's talk about deep learning. What makes machine learning deep learning? So a deep learning system usually is comprised of three things. Starting on the right-hand side, first is a neural network. That's a type of machine learning algorithm. Neural networks have been around since the 1950s. They're not new. They tend to be a lot more complicated than traditional machine learning algorithms, but they tend to generalize to big, complex problems much better than other models. The second attribute is large data sets. So using lots and lots of data to train these big complex neural networks. And because we have these big complex models and we have large data sets, we have to train them on a specialized type of hardware called a GPU or graphical computing unit, the number one manufacturer of which is NVIDIA, which is why NVIDIA stock has been doing so well over the past couple of years. So deep learning has three components: neural networks, lots of data, and GPUs. But so what, right? Why do we care? What can we do with deep learning? Why is it so special? There's actually two reasons why. First off, deep learning is helping us solve some really, really hard computing science problems. The things that MIT researchers have been working on for decades. And so when people say deep learning changes everything, what they mean is there's been a rapid explosion in solving hard fundamental problems like computer vision, which we're going to talk about in part 2, or natural language processing, which we'll also talk about. So very, very hard computer science programs that vexed researchers for decades. Well, in the past couple of years, researchers using deep learning have made faster strides on both of these problems than all of human history before. And that's one of the reasons why things are so exciting. And you can see this starting to evolve into your products. If you have the iPhone 10, or you've probably noticed how great the biometrics is, the facial recognition when you hold it up to your face, that's all based on computer vision. And if you've been speaking to your phone in the last year, you probably noticed that it gets better and better at natural language processing, that is taking your spoken words and converting them into text. Okay, so deep learning leads to fundamental breakthroughs. The second reason is that deep learning is great at handling complexity. So Andrew Ng uses this graph that I think illustrates this point really well. On the y-axis, we have performance, and on the x-axis, we have data. And so this graph measures the trade-off between the amount of data you have and your performance. And so with a human being, with people, we do really good at small amounts of data. If you show a small child a picture of a zebra, you only have to show her 2 or 3 examples before she understands what a zebra is. But as you keep adding more and more data, we don't tend to get any better. In fact, we sometimes get overwhelmed and get worse. Traditional machine learning models, that is things that are not deep learning, tend to improve very rapidly as you add more data, but eventually they kind of level out and stop getting better, right? So they might achieve human level performance or a little bit better, but then they sort of peter out. With deep learning, you can theoretically keep adding more and more complexity, adding additional neural networks, additional layers, more complex algorithms, more data, more computing power, and you can keep getting better and better and better. And that's why when we talk about the power of AI and why it's such a fundamental technology and why it's going to change everything, this chart is why. It's because we can solve harder and harder problems with this foundational technology. Okay, so going back to our intelligent signal alert system, if you wanted to figure out ways we could add deep learning to the system and make it more accurate, you could take images, perhaps from a drone or from a satellite, and feed them into your machine learning algorithm to make better predictions as to whether a signal is interesting or not. So deep learning allows you to add new data sources that you couldn't traditionally do. Okay, so we talked about the basics. There's a couple of the terms that I want you to understand. So once again, going back to our definition of machine learning. On machine learning, a developer uses data to train a model how to perform a specific task. So let's talk about data. I mentioned before at the beginning that when we talked about building our intelligent signal alert system, that we needed to gather a bunch of training data, and we were going to sit down with the scientist or the analyst and put all of the interesting signals into one spreadsheet and all the not interesting signals in another spreadsheet. So if you were paying attention, you probably thought to yourself like, oh, that sounds like a lot of work. And you're right, it is. And in fact, acquiring and building training data is generally the most expensive, highest risk part of any AI initiative. So if you are an AI entrepreneur, if you're doing an AI innovation project within your company, one of the first questions you want to ask is, how am I going to get access to a predictable, unique data source to build my product? That's also one of the reasons why I started a services company working for large Fortune 500 companies, because they have the data assets you need to do this type of work. Okay, so once we have data consists of two components. It consists of inputs, the information that you feed to your machine learning model, and it consists of outputs, the things the model is going to predict. And so if you're going to talk about any AI strategy, the first thing you want to ask is, what is my output? I can't tell you the number of times I talk to an executive or an entrepreneur that talk about doing machine learning on this, that, or that project, and I have to ask them, what are you trying to do? What are you trying to predict? I mean, machine learning is not some magic wand you wave around and it solves all your problems. So the first step you want to do when you're talking about a machine learning product or project is, what are we trying to predict? Are we trying to classify a document? Are we trying to predict the future cost of a resource? Are we trying to figure out an image? Are we going to predict the probability of the event? Are we going to summarize a document? Are we going to recommend a product to a customer? Are we going to generate a probability event for a cyber intrusion incident? Are we going to identify a spoken language? So whatever your business goal is, you want to start your strategy or product by thinking about, what am I trying to do? What is the output? The second thing you want to do is think about, do I have training data? Do I have inputs that are going to be predictive of the output? And this is often going to be one of your hardest, most expensive questions to answer. So what are the inputs? Well, if it's a computer vision problem, it's the pixels of the digital image. If it is a natural language process, it is the transcribed text from written or spoken speech. It could be time-stamped events from sensors, historical sales records, the prices of homes sold in your area. The possibilities are unlimited, but you have to identify something that's going to have some predictive power for what you want to achieve. Okay, the next item, and I apologize if you see a cat running across here. My cat's wandering around the office at the moment. The next item in our definition is models. So models or algorithms are the code that you train with your data to try to make predictions. And so I'm going to give you an example of the world's simplest model. So pretend for a second that we've got some training data. The inputs are along the x-axis, along the bottom of your screen, okay? And the y-axis are the output. And the training data you have is this scatter plot on the screen, or it's listed in the columns on the right-hand side of your screen. So you got X and Y, you got input, we got output. We want to build a machine learning model that's going to predict Y when we input an X. Well, as it turned out, you learned a perfectly good model during your 8th grade algebra class, and that is Y equals mx plus b, which you may recognize as the equation for a straight line. So in this particular instance, we're going to try to predict our output, which is Y, based on our input X, and we're going to try to discover, when we train the model, what is M and what is B. And we're going to feed these examples to the model to try to find the correct M and B. And of course, you don't really need machine learning to solve this problem. You can do it as a regression analysis in Excel. But for the sake of this example, M is equal to 0.1 and B is equal to 0.5. And that's the equation for the line. And that's the best solution that this machine learning algorithm can come up with. You can see it plotted on your screen. And that is really all a machine learning model is. And if you're interested, this is also the world's simplest neural network. It's just one sliver of a neuron in a neural network. So a bit of trivia there in case you want to impress your friends at the cocktail party. Okay, some common models you may run into: random forests, multi-layer perceptrons, convolutional neural networks, recurrent neural networks. Really, don't get caught up in models. The stuff is changing all the time. There's tons of them off the shelf. You want to start your project by using off-the-shelf models wherever you can, and researchers are coming up with hundreds of new ones every single day, and I'm saying that without exaggeration. Okay, so that wraps up our basics. We talked a little bit about the fundamentals of AI and what these terms mean. So now for the good stuff, what can you do? And I know from some of the advanced questions, a couple of you have questions about, well, how can I apply AI in my business? And I'm going to give you some tools that you can use to figure that out. So, this is the trillion-dollar question. What can you do with AI? And if you've tried to figure that out, you've probably run into a lot of technobabble, right? Understanding what a convolutional neural network is and what it can do, or an LSTM, or it doesn't really help you answer the question. So rather than talk about this low-level tech, we've developed a concept we call product patterns, or AI product patterns. And these AI product patterns are generalized ways of talking about what the technology can do as applied to a common business problem. And so we can talk about what a convolutional neural network is, which I have a little example here on the screen, but that doesn't help you very much. But if you know what computer vision is, you can think about how to apply that in banking or travel or healthcare or for online sites. And so we're going to talk about 4 AI product patterns. You can use these 4 patterns as building blocks for identifying potential startup opportunities or opportunities in your company. I use these product patterns on every strategic consulting engagement I have with my clients. When they start talking about a new idea, the first thing that goes off my mind is, what product pattern are we talking about? So let's talk about the first one. The first one is computer vision. Computer vision is a set of algorithmic techniques to learn about what's in an image and try to figure out. Computer vision is, as I mentioned before when we talked about deep learning, is one of these problems in computer science that people have been working on for generations, right? And they've made incremental, slow progress every single year. Well, in 2013, a couple of researchers decided to throw very large deep learning convolutional neural networks at the problems. And in 18 months, some very, very hard problems were instantly solved. One of the common computer science problems you may have seen is called cats versus dogs, where you just get a set of cat and dog images and you have to build an algorithm that'll predict, does this picture contain a cat or a dog? Well, before deep learning, the best researchers could get about 80% accuracy. With deep learning, this has now become a trivial task. And in about 10 minutes using off-the-shelf tools, you can build an application that will predict a cat or a dog in an image with about 98% or better accuracy. So really, computer vision right now is the most advanced form of AI, at least as applied to deep learning. And it's one of the first spots you're going to want to look for near-term product opportunities. So what can you do with computer vision? Well, you can classify images, right? Does this image have a cat or a dog? Is this someone who's breaking into my house, or is this somebody opening the front door? You can identify an object in an image, like what is this object and how do I describe it? You can do image search, retrieve a specific image from a large data set. You can do image restoration. So we did one small project with an automotive company where they wanted to have prettier cars on their website. And with computer vision, you can take a low-res car image and turn it into a high-res car image. There's also biometrics, facial recognition. So any type of problem where you're interacting with, creating, or using images is a computer vision problem. And to just give you a sense of how fast this technology is evolving and how smart it is, I like to use this little example from Google Research. This is a year and a half old, so it's getting a little bit dated, and I'm sure they've got a lot more advanced stuff now, but I think that illustrates the point. In this particular instance, Google is trying to identify, does this picture, or tries to look at this picture of a beach and identify which of the parts of the picture are people and which are kites. And you can see in some cases this is pretty obvious. On the lower left-hand side of the picture, the algorithm is able to predict with 99% certainty that these are people. And then the very top center is about 99% certain that that thing is a kite, right? So some of these are easy. But if you take a look at the far right-hand side of your screen, you see there's a kite with 96% and a person with 87%. And you can see these are really, really tiny, just little blobs, especially the little black blob of the person. So how did the algorithm know that that's a person and that's a kite from just a couple of little pixels, right? Like, how does it know how to do that? And the answer is it learned from context that kites float in the air and people are in water, but you don't see people in the air and you don't typically see kites in water. And so I just want to give you a sense of how fast this technology is evolving and the kind of things you can do with it. Okay, so if you want to look for opportunities in computer vision, if you have any application, any system that's already using images, or you think you can use images, of course, that's a great opportunity. But the one that I see more often is a company or a system or process where you have an existing workflow and you come up with ways to add images to this, like to pull, Instagram feed or product pictures and add it to the workflow to make a better prediction. Drone images, satellite images. If you have an existing prediction, you can add images to this. You can process them in a way which was just too cost prohibitive before, when you had to get people to look at every image. Training data is a challenge with computer vision. If you want to predict what's in an image, for example, this collage of faces here, if you want to predict the gender of somebody, or if somebody's wearing headgear, or if the person is wearing glasses, you're going to need to develop a set of training data. And that's going to require a person most likely to go and hand label every one of these images and identify yes glasses, no glasses with every image so that you can make that prediction. This training data and labeling data is getting easier and easier, and there are an increasingly number of third-party companies who will do this for you, either as a product or a service. Okay, so that is computer vision. Let's talk a little bit about our second product patent, and the one which honestly I think is probably, if you're an entrepreneur looking for opportunity, I would say this is the one that's most exciting at the moment, because it's changing so fast. Natural language processing is a computing technique that interacts with natural language. And what's natural language? It's language created or read by people. Okay, it's not computer language. It's English text, Chinese text. It's natural. It's the kind of stuff we use every day. The words that I'm speaking right now. So some examples of natural language processing are machine translation. Converting from one language to another. Okay, Google Translate. You see lots of examples of this. Speech recognition, you can see that in your phone, right? Talk to your phone and it recognizes your speech and it translates it into text. speech generation. You have an automated call center and you want to try to generate speech based on some background, some topic. That's natural language processing. Entity recognition or extraction. If you have a group of text and you want to pull out a specific word or the most important word, that's entity extraction. Text generation is exactly what it sounds, generating text. If you want to automatically write, you want to write a new play, if you want to write a poem, you will see there are examples of people, if you want to write a stock report based on an earnings call, there are companies out there using NLP techniques in this kind of text generation. Text summarization. What's in this email? You don't want to read all your emails, do you? I know I don't want to read all my emails, so text summarization could allow you to do that. Text categorization. Is this email spam, or is it just an email from somebody who's not a native English speaker? Chatbots and sentiment analysis. These have been out there for a couple years. So those are some examples of NLP. The reason I say that it's most exciting is that natural language processing is about 3 years behind computer vision, and it really didn't start, the researchers didn't start using deep learning as state-of-the-art for NLP until about 18 months ago. But it's rapidly becoming state-of-the-art. And if you look at all of the work that's being done on NLP now, you're seeing more and more deep learning come into it. Most papers published on NLP are using some sort of neural network, some sort of deep learning technique to solve harder and harder problems. Okay, so how to spot NLP opportunities. So obviously, if you have an existing NLP solution, you want to use deep learning. I think this goes without saying. In fact, if you're not already doing it, you're probably about to lose to competitors. Document categorization or summarization, what's in this document? Where should we route this report? With this piece of paper, should we take it to this analyst, to that analyst, or should we just ignore it? How do we triage information? College applications, how do we review college applicants? Is this a highly qualified candidate or a or a candidate we're probably not going to be interested in? What's the most interesting information in this email thread? How often have you gone into a thread on Gmail and read through email after email after email, thinking, oh my God, what do I have to pay attention to this thing? Well, you can use NLP to identify the most interesting, piece of information. And a couple of, bot identification, and one that we are hearing more and more in the financial services space is, does this email, does this memo violate any of our compliance processes or policies? Training data for NLP is harder than computer vision. It's easy for a person to look at a picture and say, oh, this is a cat or a dog or a person with glasses. But to read a document, to understand what's in it and try to classify it, it tends to be a harder problem. So it just takes more time. Additionally, if you think about just the information density, a 500 by 500 image, which is a pretty low-res image, contains 750,000 data points or numbers about it. Whereas if you look at a single sheet of paper, it has 400 or 500 words, and so you need just a lot more natural language data to train a problem than you do with computer vision. Additionally, well, actually, I should say, so really winning the game in terms of the training data with NLP is often a task of redefining the problem. And as an entrepreneur, this is where you can work with customers to figure out, what's the minimum quality standard they would want coming out of a machine learning algorithm that uses NLP. And to give you some examples, there's a paper that I read that was trying to do some text classification. So I started with a training set from Wikipedia. It took 560,000 Wikipedia examples, and it tried to categorize them into the one of 14 top-level categories. Of course, Wikipedia pages are well written. They tend to have a lot of jargon, and so the computer found it fairly easy to do this task and was able to do it with 98% accuracy. Okay, sounds great. It sounds like computer vision is everything. But then if you look at the same paper had some studies done on Amazon product reviews, and in particular, if you try to get an algorithm to predict 1 through 5 stars, whether the review of an Amazon product, they can only do so with about 60% accuracy. But if you redefine the problem and try to predict, is this review positive or is it review negative, you can get about 95% accuracy. So if you're thinking about doing any kind of NLP problem, don't start by imagining all the great things it can do for the future, but try to imagine the minimum success criteria that you could bring to the problem, because that's going to simplify creating training data. Okay, so we've got about 9 minutes left. I'm going to go through the third product pattern, and one of the most common ones is called next in sequence predictions. You'll see in the literature and training courses, sometimes they call this tabular data, but it's basically trying to make predictions based on information that's captured in your databases or tables or spreadsheets. Okay, and we're talking about things like information you gather from IoT devices or sales and marketing data or online user behavior, where they go, what they click on, what they look at, or server logs, things that are tabular that you pretty commonly see in a database. You don't hear actually a lot. Nobody gets a PhD for actually publishing a paper on next in sequence applications, and that's why you don't hear a lot about it. But really, I find that this is often one of the most useful tools you can apply in any kind of business setting, because there's so much information captured in databases, and quite honestly, it's often easy to identify what you want to predict, and there's a lot more training data. So a very common business opportunity, even if the cool kids working on AI research don't focus on it. So some examples of what you can do with next in sequence: predicting future sales, classifying log entries. Is this a cyber attack, a system failure, or is the machine about to crash because it's overheating? Identifying fraud, credit card fraud. Trying to predict who's going to buy. I got a website, I got people coming on, I'm going to use machine learning to try to predict, okay, based on this person's behavior, they're likely to buy. In fact, they're likely to buy that product right over there. Very common use of next in sequence. So I mentioned structured data, and so let me spend a moment on that for those that you don't have a computer science background. I'm talking about the kind of data you would expect to be stored in a database. Although you could store a blob of text like a tweet or a document in the database, typically that's not what you do. Usually we'll see those on a file system. I'm talking about things that are categorical or continuous fields in a database. So what are categorical fields? Things that have a finite set of examples, like store. Is it Reston, Chicago, or San Diego? It's got a finite number. Or continuous data, numbers that can go from negative infinity to positive infinity, that have an infinite number of values, like sales or temperature. Or if you're using data that says a Unix timestamp, it's timestamp in seconds, right? All of this is categorical data. I'm sorry, is tabular data. So if you want to look for next in sequence opportunities, it really is, it's usually where you want to start is look at your existing data, look at your existing processes, look at your KPIs. What is your organization accountable for? Are you trying to boost sales? Are you trying to increase the workflow of a particular operational unit? Are you trying to accelerate the closing of a case? Do you want to close more cases faster? You will typically look around an organization. If you look at their KPIs and what they're measuring, you will often be able to identify next sequence opportunities. And usually you can also improve those by finding new third-party data sources to add to any existing business process. So instead of trying to predict sales based on past sale behavior, you can also add in the weather, right? Look at the weather for a particular region and figure out, people probably shop more when it's nice and sunny out, and they don't shop as much when it's snowy and bad weather. Okay, training data is a bit of a different problem in next in sequence. So you, rather than having to go out and create new training data, you probably have plenty of data in your database. Training data actually becomes an engineering problem, where your data scientists are going to have to go into the database, and they're going to have to do what's called feature engineering, which is looking at your data and trying to derive features or inputs that are going to be predictive of your output. For example, you might have a timestamp associated with every sale, but you can take that timestamp and you can convert that into a feature which says day of the week. And that way your algorithms can more easily identify trends in the data by pulling out specific features that might be more predictive. Okay, so we've got about 4 minutes left here before we'll start taking questions, and I want to leave plenty of time for Q&A. So the final pattern is, and the one that we see sort of the least, is collaborative filter. A collaborative filter is used when you have effectively a matrix of users and items. And so the most common use of a collaborative filter is a recommendation engine. So if you have an e-commerce site or you have sales transactions, you're often going to want to try to predict what is this person likely to buy based on past behavior? Well, you can look at their own past behavior, but if they're a relatively new customer, that might not tell you a lot. Instead, a collaborative filter is an algorithm that looks at your past behavior and looks at all the past behavior of people like you and tries to make predictions on what you might like. So the example I love to give is myself and my Netflix. So when it's a Friday night and my wife and I wanted to decide to figure out what to watch, we open up Netflix, and the first thing I start doing is throwing a temper tantrum and say, no period pieces and no rom-coms. Like, I don't want to watch a silly rom-com. But my wife has figured out that if the rom-com has Vince Vaughn in it, or Ben Stiller, or one of the actors that I like, I will be excited and see it. So you won't. That's not an easy type of. That's not an easy type of logic for algorithms to generalize and figure out. But I would bet if you looked across all the different married couples and looked at across all the different men and the type of rom-coms they like, or the movies they like, I would bet you'd find a cluster of people who like rom-coms and Vince Vaughns. And those people probably have similar preferences to mine, and you can make a product recommendation that I would probably like. So that's a collaborative filter. Usually see it most in like advertising campaigns or product recommendations. And so we're talking about these 4 product patterns, and this really is the first filter that you can use when looking for AI opportunities. Of course, this does not cover the realm of all AI research. There's reinforcement learning and adversarial models, a lot of stuff that's happening on the cutting edge, and we do some of that with our clients. But this is a good first triage, and if you're new to this topic and you want to find opportunities, these 4 product patterns can be really useful for looking for business opportunities. Final point I'll say is that with AI and neural networks and deep learning is so amazing, you can actually combine these patterns. And so the inputs to these models are just a series of numbers. And the outputs are also a series of numbers. And you can connect these different patterns together almost like Lego blocks. It really is astounding if you come from a computer science background. And I'm amazed by this every day. But you can build more complex neural networks and successfully train them using off-the-shelf tools by combining patterns using some of these techniques. Okay, and so final step, I've got a quiz to go through, which we can take. But before we go to the quiz, I'm going to leave plenty of time for questions. It looks like there's a lot in the Q&A here. So we're going to skip the quiz. Our book has some quizzes in it if you want to brush up on your knowledge. Let me just finish up there and say thank you very much for your time. If you want to talk to us more, my best recommendation is to contact my business partner, Russ Rands. You can contact him and connect with him on LinkedIn. He's at russ@perlego.io. If you connect with me on LinkedIn, I know there are hundreds of you on this call. I will not recognize you, but just mention when you try to connect with me that you took the e-seminar from MIT so that I can connect with you. Thank you very much. Let's take some questions. Mariah, do you want me to jump in and start responding to these from the top, or do you have specific ones you want me to call out?
Yeah, that would be great if you just start as you see fit.
Okay, so from anonymous attendee, which AI subfield between machine learning, NLP, robotics will truly have the biggest impact on businesses? So I will say that, let me repeat the question. Which AI subfield between machine learning, NLP, robotics will truly have the biggest impact on businesses? And of course, if you were paying attention, I don't know how to answer this question because I don't really understand it. NLP is an AI product pattern as we described it, which is a type of solution that can be solved with machine learning. So NLP, for the most part, is machine learning, and a lot of robotics applications use computer vision and machine learning. So I'm not sure quite how to answer that. And if I could predict which ones would make the biggest impact, I would be investing in those companies and not telling you. Anonymous attendees. Okay, so how should data be collected and structured to generate good insights from machine learning models? What kind of machine learning models are available, and what situations should they be used? Okay, so I try to answer that with our product patterns. So I guess what I can say is that the data really depends on what you're trying to do. So let me answer this question a different way. if you have an idea of what you want to do with AI, the first thing you want to do is figure out what is my output. What am I trying to do? What am I trying to create with this? What am I trying to accomplish with this information? Am I trying to predict who's who's in the picture, or am I going to try to predict which is next week's sales? The next thing you want to figure out is, do I have inputs? Do I have data that might be predictive of whatever that output is? And if you think that answer is yes, then you might be on your way to finding an opportunity for using AI. Which type of machine learning models are available? There are infinite. To give you a space of how fast this is changing, there are on Archive, which is a preprint publication site, there are 100 papers published every day on machine learning. I mean, that's effectively a conference every single day on machine learning. And if only 10% of those papers are relevant and have new and innovative models, that's more than I have time to read. So there are infinite number of models, and there are ones coming in all the time. You don't really need to worry about that. You need to focus on what you're trying to solve, and if you have inputs that allow you to solve it. Okay, so since getting good training data is an impediment to supervised methods, are unsupervised methods that don't require training data not yet sophisticated enough to compare in the quality of prediction with supervised methods? I.e., do we always need training data? This is a good question. So for the most part, if you look what people are doing with unsupervised machine learning, is they're typically taking a set of data and trying to cluster it or organize it around a particular set of values that they're looking for. That's typically where you see most of the unsupervised stuff. These terms like unsupervised and supervised learning, when you get into the details and you look at the problems you're trying to solve, they're never that simple. And even people who are doing things that are quote unquote unsupervised, a lot of times it's semi-supervised. In other words, they have some training data and they're supplementing it with other data in some way. And in some domains, like we're working on some reinforcement learning projects right now, people think of reinforcement learning as totally different than supervised learning. But I can promise you that we're having to generate examples. On the project we have, we're having to generate training data and examples, and building and organizing that data still remains one of our biggest challenges. So for right now, data is still king. We may reach a time when we don't need it as much, but as far as like practical business problems, mostly for right now, I see supervised learning is still being needed. What kind of off-the-shelf tools are currently used in the industry for computer vision and AI solutions? So there, if you go into any of the common platforms, PyTorch, TensorFlow, or Keras, FastAI, you're going to see an example of the kind of off-the-shelf tools. For the most part, everything is sort of off the shelf, in that when a researcher discovers something new, an algorithm, there's a tremendous amount of industry pressure to publish right now, because the researchers need to get feedback from colleagues to figure out if they're really on something. And so most of the most innovative techniques that are out there, people are going to publish. And so it's off the shelf in that if you go to a site called Papers with Code, you can find the code you can use to achieve the same results as what the researchers have. Off the shelf, you can look at Amazon AWS, and you can find computer vision algorithms like VGG16, which is 5 or 6 years old, that you can use to make image classification techniques. And there's off the shelf NLP applications that you can get readily. And most of the next-in sequence prediction models you can get out of a library called scikit-learn. So a lot of this is out there. The bigger question is organizing the training data and getting it pulled into a way you can use it. Again, I would spend less time thinking about models, because models are always changing, and there's lots of off-the-shelf ones. Think about data. What about for developers? Any suggestions for the computer vision AI solutions for developers? Well, if you're a traditional software developer, then I would just, if you're a software developer that doesn't have any sort of machine learning background, then I would encourage you to go take a course called fast.ai. It's an AI course for software engineers. It's taught by Jeremy Howard, and it is, I believe it's by far the best way to learn AI out there, far better than anything else you'll see on Coursera or Udacity. Fast.ai, I cannot recommend it enough, and you will get more than you can ever possibly use as a developer. With a web app AI service, what is a good price point, considering that initially one may have to use a cloud AI service before in-house solutions are feasible? So almost all your cost associated with AI is going to be data and people. So it really comes down to, do you have the people that can either configure the algorithms for you, or do you have the data they can use to make predictions? And there's kind of, there's this industry idea that, oh my God, there's a massive shortage in AI and there's a massive shortage of talent. There's not a massive shortage of talent. Like, there's a massive shortage of talent for every tech skill, right? It's hard to get good Java developers, but there's also a lot more Java projects out there. There's more people who are Java developers. There are fewer people who know how to do AI, but it's also fewer projects. So I would encourage you to start, going to meetups, meeting people, look for talent that can help you get your project off the ground. So when you talk about price, that's really what it's going to fall into. The computing resources, it's cheaper at the margin to build your own deep learning box than it is to run an Amazon cloud, but it's not your major cost driver. Knowing that you have done work with insurance and financial services companies who are typically risk averse, in what area of the business have these groups been willing to accept that risk and jump into the AI waters? Are they starting small with something like competitive search for legal, or jumping into the deep end with deep learning and underwriting? I unfortunately cannot answer that question because of work I'm doing with my clients. And so, excellent question. I think if you looked around, my suggestion is just Google the question and look at a site called Kaggle.com and look at the projects that are going on. It's all over the place. We're working with some of the companies in financial service, and we're doing some incredibly innovative work that is really going to be disruptive, and it's incredibly exciting. And you'll find other situations where they're trying to automate their sales and marketing processes using techniques and tools that have been around for a couple of years. And so I guess what I would say is, for those kind of questions, start thinking about AI as a fundamental technology. Think of it like the way you think of electricity or the internet or computers. You don't ask how an industry uses the internet because it's so ubiquitous. And that's the way AI is going to be. It is a fundamental building block that's going to change everything. So almost anything you can imagine using technology for, there's somebody at one of these companies thinking and working on it. Okay, try to get answer some folks here who haven't had questions. Do you think that unstructured data such as emails and social media posts would have any major effects on big businesses? And what is the best way to deal with such type of data? It's an NLP problem. So natural language processing, and you will find tons of examples of how that will have effects. And so that's where unstructured data, that is text data, is an NLP problem. Appreciate someone calling me Dr. DeWalt. Unfortunately, Dr. DeWalt is my mom, actually. I quit after my master's degree, but thank you. What is the period you expect that AI would be available in the Middle East? I assume that it's already available in the Middle East. I would imagine, I've met people from that region who are researchers and are building products, and so I would say it's already there. Let's see, the last couple of questions. What are the real applications of NLP in the industry? Could you recommend reading materials to study AI? So again, fast.ai is the course that I most recommend, and applications of NLP, tons. I think I mentioned it in the presentation, and there's more in our book. But yeah, NLP is one of the hottest areas. But for the most part, any business situation where somebody's generating or reading text is an opportunity for NLP. Computers are going to be doing all of that for us. Let's see. I think I answered this one. Do you think unstructured? Yeah, that's one I just answered. I think that's the last of our. Our Q&A questions, and we've got about 4 minutes left. Mariah, did you want me to? Okay, some more coming in. What would you recommend for startups from third world countries where the data is not available as in other parts? thoughts. I would say that training data is a challenge everywhere. Even in the United States, startups don't have data. You've got to figure out how to partner with or work with a bigger company to get access to proprietary data. I would start looking for, if you're looking for a unique data set for your region, and I lived in Asia for 3 years and worked with a lot of entrepreneurs in Asia, so I've got some experience in the startup community there. I know you've got a lot of challenges, but I would just say look around. What unique training data sets can you get? What does your government have? What's being published? Are there data sets there in analog form that you can turn into digital form? So maybe your opportunity is not actually doing AI in the training data. Maybe your opportunity is to create the training data if you live in a region where that doesn't exist. Okay, that's the last of our questions. Anybody else have another question? Okay, then with the last 3 minutes, I'm going to make you endure my quiz. So we're going to go through this real quickly. What is machine learning? What are some pros and cons of machine learning? So machine learning is a different way of building software where you take training data and you give it those examples to a model and teach it how to perform a specific task. The pros are machine learning is great at abstracting at more and more complex logic. It tends to be more robust to changes. And as you get more complex situations, it gets easier to manage. The cons are you got to get all this training data. And if it's a simple problem, a lot of times it's easier just to write regular code. Machine learning is not a magic wand for all your problems. What are your thoughts on the emergence of deep fakes? How can we ensure that AI is used ethically as it becomes more prominent in society? So I think this is a really good question. Unfortunately, the ethics would be an entire presentation. So I've seen the deep fakes. I guess we'll see how this goes. But we've had, if you listen in the United States right now, people don't seem to believe the facts, and so I guess, or they want to make up whatever facts they have. So I'm not sure deep fakes are going to have much of a change over what we have now. I mean, it's getting easier for people to do fakes of video, but we've had Photoshop for decades, and we'll have to come up with ways that are making authenticity. If there is a fake, who's ever being challenged will claim it's a fake. You can already do a lot with Photoshop. And unfortunately, I think we live in a situation now where people are going to believe whatever they want to believe. AI and ethics is a really interesting problem. It's one we think a lot about. It's more than I can go into in 30 seconds. I'd say if you're looking at the real sort of ethical issues around AI, the biggest one that I see is job loss. And that is automation through job loss is coming, and we all have to be ready in democracies to respond to it. Okay, I think we are just about at our end. Mariah, anything final for the group before we go?
I would just like to say thank you so much, Kevin, for your time. We've really appreciated it. And also to everyone that is still listening, this webinar or e-seminar will be available online. If you look under our Learn tab, and this will be under our How to e-seminars. So you will be able to find it later, don't worry. And yeah, just thank you so much, Kevin. It's been so wonderful to have you on.
Thanks, everybody. Really appreciate it. Thanks, everyone at MIT for organizing this. You made this very easy. You did a great job.